Alright guys, so this is our second video on our extra credit project. This part 2 video is going to be how we enter our formulas that we came up with in part 1 from our hand calcs. How are we going to enter those formulas into our Excel spreadsheet here so that we can get automatic calculations for our reactions and our shear in moment at any location X, okay? So if you guys will recall, if you're looking at your hand calculation sheet, we found that our reaction for our right support was PA over L. Okay, so I'm going to go over here to my cell, this cell B10. That's going to be the cell that's calculating the reaction at the right support. And I need it to be equal to P times A over L. So I'm just going to type this in as an Excel formula. And an Excel formula always has to start with equals, right? So we're going to say equals, and then we're going to click on the cell that we're going to enter our P value in, which is B2. Then we're going to say times, so that's P times, I need A, which will be that one. And then I'm going to divide by L, which is this value here. So once you type that in, we're going to say enter. And right now it's going to give us a divide by zero error because we are not correct. Let's go ahead and go to our validation on the last page of the instructions for this. And let's type in our validation numbers that we did, so that we're going to use to check ourselves. So in the beam 1 validation section, if P is equal to 3,000 pounds, A is equal to 5 feet, and B is equal to 18 feet, we need to type in a little formula right here for what L equals. So we're going to say L is equal to A plus B. So we're going to say equals, and we're going to go to A, and then we're going to say plus, and then we're going to click on B, and then we're going to say enter, right? So that little formula there will calculate what our total length is. No matter what you change A and B to, I could change A to 8. So if it's 8 and 18, we should go to 26 feet, right? That's correct, but we're not there. We're checking if A is 5 and B is 18. So that makes L of 23. And this tells me that my reaction at the right support is 652.2 pounds. Now, if you look at the validation spreadsheet, at the validation part of the project, you'll see that that is correct. Okay, let's move on to the reaction at the left support. We found that the reaction at the left support was equal to P times B over L. So I'm just going to type this formula in too. We're going to say equals, we're going to click on P, we're going to say times B, which is the 18, and then we're going to divide by L again, right? And we click enter. And the reaction at the left comes out to be 2,347.8 pounds, which lines up with what our validation tells us it needs to be. All right, so that's good. So here comes the little bit of a tricky part of how to code into the Excel formula. What formula to use depending on what the value of X is down here. Right here we're going to type in a value for X. If we look at our validation, we're given the values of the shear in the moment for when X is equal to 3 and 12. So we'll start off for X equals 3 as our point that we're looking for, and let's type our numbers in, right? So for our shear equation, if X is less than A, the shear was just equal to PB over L. All right. But when X was greater than A, the shear was PB over L minus P. All right, so what we need to do is tell Excel which equation to use based on what we type in for X. All right, so we do this with a simple if statement. All right, so to do an if statement in Excel, we type equals if, and then we open parentheses. So the first part of our if statement in Excel, as you can see from the text that's popping up, is we need to give it the logical test, right? This is the if this equals this, or if this is greater than that. then this is what we do, right? So our first test is going to be if x is less than a or equal to, less than or equal to a, we're going to use the v equals pb over l equation, right? So for the logical test, I'm going to say if, I'm going to click on x. So if x is less than or equal to a, which is 5 up here, then if that's true, the next part of our if statement is the value if our logical test is true. If x is less than or equal to a, what do we do? And if that's true, we're going to just do pb times l, right? So we're going to take p times b divided by l here, and that's it. That is the value if true. Now, the last part of the if statement is the value if false. So if b14, which is x, is not less than or equal to b3, which is a, so this is our if x is greater than a situation. If x is greater than a, then our shear is pb over l minus p. So we just type that in as well. So we say p times b divided by l. And then we have to subtract out p as well from that formula right there. And the only thing you've got to remember now is to hit the in parentheses to close off the formula, and that should be correct. So we're going to hit enter. All right. So shear at x comes out to be 2,347.8 pounds if x equals 3 feet. Looking at the validation, that is absolutely correct. We also know our shear value if x equals 12 from our validation. All right, so if I type in 12 for x and hit enter, my shear at 12 feet, which is 12 feet from the left support, right? This is 12 feet from that far left support. The shear goes to negative 652.2. Again, that is correct from our validation that we've been given. All right, so let's go back to x equals 3 then, and let's work on our moment equation now, right? It's going to basically be the same thing. We're going to have an if statement. If x is less than or equal to a, use this moment equation, else use this moment equation. All right, so let's just type it in again. We'll say if x, which is this cell, is less than or equal to a, which is this cell, I need to use this moment equation, which is just PB over L times X, right? So I'm just going to click these values in. So P times B divided by L times X. Boom. So PB over L times X if that value is true, or if that test is true, right? So then the other one is if the value is false, right? If B14 is not less than or equal to B3, so if X is greater than A, we need to use our other moment equation, which is PB over L times X minus P times X minus A. Okay, so we're just going to type this in again. P times B over L, that's PB over L. I need to multiply by X, and then I need to subtract out P times X minus A. So P times, make sure you get your parentheses right here, X minus A in parentheses for that one, and then I need another in parentheses to close out the if statement. Okay, press enter. So if X equals 3 are at a value of, if X equals 3, which means we're on the left side of our load because A is equal to 5. If X equals 3, our moment then is equal to 7,043.5 foot-pounds, which if we look at our validation sheet, that's the value that we should have got. If we change our value to 12, we should get a moment of 7,173.9 foot-pounds. Again, looking at our validation sheet, that's what we should get. Okay? So that's got this one done. This equation, this first beam is done. This is all you need to do. And what this sheet allows you to do is to come in here and type in any value for the load, any values for A and B, and you can get what the shear and moment are at any location. All right, so let's just do another example here. Maybe P only equals 650 pounds, right? And A is 13 feet and B is 22 feet, okay? So we got a total beam length of 30, we got a 35-foot beam, 650-pound load. It acts at 13 feet from the left support. Maybe I want to know what the shear is. Maybe I want to know what the shear moment is at 10 foot from the left support. So I just type in 10. Our shear is 408.6 pounds. And our moment is 4,085.7 foot-pounds, right? So this spreadsheet, now that you've got this spreadsheet developed, you can come in here and for a simply supported beam that's got a single concentrated load on it at any point along the beam, you can come in here and quickly see what the reactions are going to be, and then see what the shear and the moment are anywhere along this beam that you type in, right? All right, so that's it. So now it is up to you guys to do beams 2 and 3. Basically do the same thing for beam 2 and 3, where you're going to come in here and type in what's a value for the uniform load, and type in a value for the length of the beam, and then you're going to come up with equations for the left and right reactions, and then you're also going to come up with equations for the shear and the moment at any location X, right? So that way, when you're going to do that in your hand calcs, and then you're going to bring those equations you get from your hand calcs, put them into this spreadsheet, so that way you could put in maybe 10 foot here or something, and it tells you what the shear and the moment are at 10 foot, right? Same thing for beam 3, except this time it's a cantilever beam with a triangular load. All you got to type in is W and L, and then your spreadsheet should calculate the rest of it. All right. So we've done beam 1 together. This is what I'm looking for, right? I'm looking for that validation of 3,005 and 18, and then you can look at the values for 3 and 12, and they should line up with what the validation is too. All right, you can use the validations for beams 2 and 3 as well to check to make sure that the formulas that you come up with for beams 2 and 3 are correct. All right. So we've done beam 1 together. Beams 2 and 3, those are going to be all you. Make sure that when you get done with this little extra credit project that you keep up with all your hand calcs. I want those to be turned in, as well as your Excel file. Please rename the Excel file to, extra credit project John Smith, right? Include your name in the Excel file. And then email that to me, and all of this is going to be due just sometime before the final exam. So if you get done with it a week before the final exam or whatever, just go ahead and send it in. Okay. Keep in mind too that I'm not going to give any partial credit for this, because I've basically given you the answers by giving you the validations. So you need to work backwards and make sure that your formulas are correct. There's no sense in turning it in if your formulas are not correct. You should be able to work on this and get the exact right answer, because I've given you what the answers should be with those validations. Okay, so make sure you get them all right. Each beam is going to be worth 10 points. So maybe you can only get beams 1 and 2 figured out. Maybe you don't get beam 3 figured out. Go ahead and send that in. That way you can get 20 points, and you won't get the full 30. All right, it's whatever. You should have at least 10 points now, because we did beam 1 together. You've got everything you need to do beam 1. All right, I believe that is everything for this project. If you guys have any questions, just make sure you email me. All right.